Hey guys, you made it to Unit 2.2. Here we go again. How can I solve quadratic equations by factoring? First, we're going to take a look at GCF. What does that mean? Of course, we all know that is greatest common factor. And by definition, the greatest common factor is the largest quantity that is factored of all the integers or polynomials involved. So, when finding the GCF of a list of integers or whole numbers or terms, these are the three steps that we need to do. First, we need to find the prime factors of the number, identify what they have in common, take the product of all common prime factors. One thing to pay extra attention to is if they have nothing in common, then that means the GCF is 1. Okay, super important. Let's see how this works. So, uh, most of you that had me from ninth grade know I like to use the factor 3. So, the factor 3 say 12 broken down is, I just keep breaking these down until I find prime numbers. So 12 is actually 2 times 2 times 3. And I know by head 8 is 2 times 2 times 2. So if you're not sure, break this down. 4 times 2. 2 is prime, but 4 is not prime. 4 is actually 2 times 2. Then I look for what they have in common. I see a 2. Oh, I see another 2. So all that means is that the GCF is 4. 2 times 2. Now let's look at another example. Here I have 7. 7 I know it's prime, so I'm not going to worry about that. 20 I know is 20 is 10 times 2. 2 is prime, and 5 times 2 is 10. So this becomes 5 times 2 times 2. Now I look for, is there anything in common? Nope. So that means my GCF, when it has nothing in common, my GCF is 1. Now what about if I have three numbers? 6, I know it's 3 times 2. Good. 8, I know it's 2 times 2 times 2. That's what we just did. And then 46 is actually 2 times 23. 23 is prime. Now look for this. Look, look, look. Let's see. Do they have anything in common? They all have a 2 in common. So that's the only thing. So all I do is GCF is equal to 2. That's it. Nothing else. Oh, what about this one? I see it has some variables inside. So let's see. 6x to the 5th. 6 is actually 3 times 2, and then x to the 5th is x times x times x times x times x. 5 times 4x to the 3rd. 4 is 2 times 2, and then 3 x's. The exponent tells me how many x's I need to have. They have a 2 in common. They have an x in common. They have another x in common, and one more x. So if I was to write this, the GCF is equal to x to the 3rd. X times x is x to the term. X to the 3rd. Here we go. Now when we're doing factoring polynomial, the first step in factoring a polynomial is to find the GCF of all its terms. Then we're going to write the polynomial as a product by factoring out the GCF from all the terms. The remaining factor in each term will form a polynomial. So, 3 simple steps. Again, all we're doing is breaking this down. 6 x to the 3rd is actually 3 times 2 times x times x times x. 9x squared, 3 times 3 times x times x. And 12x is 3 times 2 times 2 times x. Same thing like we do, find a GCF. They have an x in common, and they all have a 3. Notice they all have to have it in common, okay? If it doesn't have all of them in common, then we have an issue. So 3x is outside. Now what goes into parentheses is what's left over. So from 6x I have 2x squared minus, which comes from up here. What's left over here? 3x and plus from up here. and then I have 2 times 2, which is 4. And that is when we've all we're doing to factor a polynomial. Now let's see one more example. Looks a little hectic here. So this is 14 x to the third y. 14 is 7 times 2. I have 3 x's and a y. 7x squared y. 7 is prime, 2 x's and a y. 7xy squared. 7 is prime, 1x, 2y. Now what we do, they all have a y in common. They all have an x in common. And look at this, they all have a 7 in common. So if I was to write this, I know 7xy will be outside. What's left over here? Good. 2x squared plus, coming from the top here, I see an x left over. Then this is minus, and I see a y left over. That's it. That's all how we factor a polynomial. So moving on, how do we solve quadratic equation by factoring? So we have did this numerous times, and you did this with Miss Shiny. So 5 steps. Write the equation in standard form. Remember, we talked about standard in the previous lesson. We said standard form is anything in y equals ax squared plus bx plus c. Factor the quadratic completely. We're going to set each factor equals to 0, solve it, and then check it. Let's see how this goes. A, B, C. 1, -3, C is -18. Remember the x method. A times C at the top, which is -18, and -3, my B term is at the bottom. So two numbers, when I multiply it, I get -18, but when I add it, I get -3. Perfect. 6 times -3. But remember, not the -3 is, let's just take that out. Not the -3 goes positive. Yes. AC is at the top, -18, -3, and it's 6 and 3, but the negative goes on the 6. Okay, be extra careful. This actually we write it as 6 times 6 minus x minus 6 and x plus 3. Now most of us have been familiar with this, so what we want to do now is set these equal to 0 and then solve. So I'm going to do x minus 6 equal to 0 and x plus 3 equals to 0. Remember, quadratic has two solutions. So add 6 on both sides. This is cancel. X is equal to 6. Here, if I go ahead and solve this, I would minus 3 on both sides. 3's are cancel. X would be equal to -3. And here are my two solutions to this quadratic. These are actually where the graph crosses the x-axis. Perfect. Now let's take a look at this here. A is equal to 1, B is equal to 6, C is equal to -7. A times C is -7, and 6 at the bottom. Perfect. Two numbers, when I multiply it, I get -7, but when I add it, I get a positive 6. Yep, 7 and -1. So we write this as x plus 7, x minus 1, but remember, now we're solving, so we make them equal to 0. So set this up as x plus 7 equals 0, or x minus 1 equals 0. And when we solve this, we get x equals -7, or x equals to +1. Okay, we should all be able to get up to here, and then all we're doing is setting them equal to 0. Now let's see here. A, B, C. This one's kind of special. A is equal to 3, B is equal to 7, 6, -6. -18 on top, 3 times -6, and 7 at the bottom. So 9 times 2 is 18, and I need one to be a negative. Good. 9 times -2 is -18. 9 plus that -2 will give me positive 7. Remember, these are special because A is greater than 1. So what do? We have to replace it. Yes. we replace our b term. Remember this from unit 1. All I'm doing is replacing my b term, which is a plus 7x, with plus 9x minus 2x, which is the same thing. Then after I do that, I'm going to factor out, just like we've been doing. They both have a 3x in common. What's left over? X plus 3. Now let's look at this part here. They both have a 2 minus 2 in common, so this is x plus 3. And remember the little hint I gave you that these two right here will always be the same exact thing. So since they're the same thing, we're going to write it once, and then these two that are outside here, we're going to give them their own parentheses. Now that you have something similar than we had before, we're going to just go ahead, x plus 3 equals 0, and solve for these. So minus 3 on both sides, x is equal to minus 3, that's one answer. Here we're going to have 3x is equal to 2, and x is equal to 2 over 3. First I might add 2 on both sides and then divide it by 3. Great job, guys. One more to go. So here again, a is 9. Whoopsie, look at this. Looks a little funny. Before I even do the a, b, and c, let's rewrite this really quick. It has to equal to 0. 9x squared minus 24x plus 16 equals 0. I'm moving this on that side. So now a is 9, b is negative 24, and c is 16. Good. So now let's use a different color, x. So what goes on top? Oopsie. What goes on the top? 8 times. So 9 times 16 is 144, and at the bottom it becomes negative 24. So two numbers, when you multiply it, you get 144, but when you add it, you get negative 24. Perfect, guys. Negative 12 and negative 12. But remember, this is special because a is greater than 1. So I want to rewrite this. This is going to actually be 9x squared minus 12x minus 12x plus 16 equals 0. All I did was replace this term right here. Now look for what they have in common. They have a 3x. Yes, they have an x in common, so that becomes 3x minus 4. Now look at the second part here. What do they have in common? 4. Excellent. So this have a minus 4 in common, and when you take out 4 from this, you're left with 3x. I need a positive, so this has to be a negative, equals 0. And remember what I told you, this and this always going to be the same. So if I was to write that back, 3x minus 4, and then here, oh, look at that, 3x minus 4 is the same exact thing, equals to 0. So since both of these are the same thing, we have two options now. We can write it as 3x minus 4 equals 0. That's it. We don't have to do both because we know it's going to be the same exact answer. So we have 3x is equal to positive 4, divide by 3, x is equal to 4 over 3. Perfect. So notice this. That's why we only have one answer now, okay? That means your graph, when you graph your parabola, it's going to look something as, if this is my axis, 3, that's actually 1 1/3, so it's something where here is going to look like a graph that looks like that. It only touches it at one point. Okay, that's the end of 2.2. So what you're going to do is work on your portfolio. Remember, solving quadratic by factoring out the GCF. Remember, complete your checklists.